Hey everybody, I'm Bill Graber, and
I'm
joining
Jake.
me, yeah. So thanks a lot for joining. We're going to give you some updates today on whole building air tightness testing and some of the things we've been up to at the Energy Conservatory to make that testing easier to do. This is sort of a growing part of, the industry. More and more people are testing bigger and bigger buildings in many of the states now, and code is driving that. And so Jake and I are going to take you through what we're seeing. We get a lot of questions on this, what we're seeing, and some of the things we've prioritized to try to support people out there doing more of this testing. So one of the other things I wanted to say is we're seeing this is, historically has been an engineering firm based market, that's done not very often. And now more and more with the code change, we're getting a lot of questions from people who have historically done single fan residential blower door testing, starting to get asked to do tests where they might need 2 or 3 fans because it's a small commercial space, even a store like a 7-Eleven or something like that, and that needs to be tested. And how do they migrate from what has historically been a single fan test to that kind of testing? So there's a lot of questions that we've been getting on that, and that's what we hope to, at least if we don't answer them all on this call, what we'll do is at least get you engaged with us in terms of what resources do we have for you. Jake, that's kind of my introduction. Anything you want to add to that, or should we jump in?
No, that sounds good.
Okay. All right. So what I'm going to do is I'm going to share, if I can do this right. We'll see if I can. We'll share this PowerPoint. Yeah, and then you're still seeing us. So great. So again, thanks for joining. Jake, why don't you introduce yourself, and then I'll introduce myself, and then we'll dive in.
Hi, my name is Jake McAlpine. I've been working at the Energy Conservatory for about 5 years now. My background was in the weatherization assistance program. So I started out as an auditor, did a lot of field work auditing houses, mostly single fan, some guarded testing, some multi-fan testing, but it was definitely an area that I didn't know a ton about. So I've gotten into that over the last few years, and I really find it quite interesting. Actually, it's kind of, in my mind, still kind of like the cutting edge of blower door testing. There's some awesomely crazy buildings that people are testing, and it's fun. So that's me.
Yeah, great. I'm Bill. I'm one of the partners here at TEC, and I've been here. Actually, Jake, you'll be here 6 years in June. You and Chris Hughes both started 6 years ago, coming this June, and then I'll be at 7 by the end of summer. So yeah, we've all been around about the same amount of time. And I got to TEC through Steve Rogers, our president, and he and I worked at Emerson for many years together. And so that is who we are. And this is the agenda we had queued up. We'll very briefly talk a little bit more about whole building air testing and why it's growing, what are the requirements, what's different about it. And then we'll jump into our capabilities. That's where we have some updates to talk about, some things we've been working on to make our software and fans and gauges a little easier to work with. And then we'll talk about upcoming training events. One of the big investments we've made at TEC in the last 2 years is a move to a new building. And as we moved into that building, we have built a training center, what we're calling the Conservatory for Building Diagnostics. And you'll see a little bit more about that here at the end, and some of the training that we have available, not only for whole building air testing, but in general. So let me take us through a little bit of here, and then Jake will comment more about our capabilities. So code requirements is really, that's historically what's driven blower door testing in residential, and it's what's doing the same in commercial blower door testing. And so, what this is from HUD Exchange, this map, and what it's showing is what code, or what is the equivalent code being requested. And this is showing ASHRAE 90.1 2019 or IECC 2021. Those are the 2 code requirements that are driving this test. And so as that gets adopted, then commercial buildings having blower door tests is where you see it. And so where you see the dark green and where we've added the red stars is where we're starting to see some activity In some of these states, like Washington State and a few others, it's been, going on for several years. But more and more states are being added, and so it's code that's driving this, I would say, increasing amount of testing. And so, I show this slide just to kind of start the discussion of what's different about commercial blower door testing. So what, isn't it the same? And in many ways it's the same, but there are many, many things that are different. And so just to remind us all, in a blower door test, what we're doing is we're trying to change the envelope pressure by 50 pascals. There's a natural pressure that's on it from stack and wind and mechanicals, and we want to change that in 50, and we want to measure how much flow that takes, and that's a blower door test, right? And then on a residential, there's some assumptions that are very easy to comply with. Do I have a single zone? Have I opened up all the bedroom doors and all of the doors in the house to make sure that I have a single zone? And it's some of those types of things that, as you get into bigger buildings, becomes harder to achieve, and the challenges of making sure that's what you have. And then if you don't have it, how do you still get a valid test of, testing the envelope for how airtight it is? So conceptually, it's no different, but the details and logistics are much harder. So that single family residential test, whether you're doing weatherization testing or others, a lot of times things are tested, and the standard reference is E779, the ASTM standard. And that's also used a lot for whole building testing historically. More recently, there's been a new one added that is more specifically, the language in it is more specific to doing, large or multi-zone buildings, and that's the ASTM E3158. And then a lot of people who were doing these tests historically were doing it because the United States Army Corps of Engineers was asking for it. They were testing, their buildings, and so a lot of the testing prior to some of this code change was USACE testing. Okay, Jake, feel free to jump in if you think I'm missing anything. Otherwise, we're just going to keep plowing along here. So I'm going to just take us through two more slides on 3158, and I'm not going to go through the details, but I just want you to see the kinds of details that are called out in the standard. And so if you're being asked to do tests of whole buildings and you've never done much of that, you're a residential rater, or you're a residential home performance person that's seeing this as an opportunity, you'll probably be requested to do either E779 or E3158, or it might be your choice. Meaning if it's not U.S. Army Corps, you're not doing stuff for the Army Corps, for the military, it would be one of these two standards. 3158 is more prescriptive. It has a little bit more details to help you know, am I doing this right? And so they have things very specific about pressure uniformity, acceptable ranges, test durations, things that are more, and like E779, it's got acceptable ranges of C and N, but or I should say for N, but it's broader based on the kinds of Ns that you'll see in bigger buildings. So this standard helps define categories that are more specific to bigger buildings. And then the other big change here is, if we're doing an airtightness test, you're doing an envelope test. And that most of the time is what you should be doing if your job is to say, how airtight is this building, or how well constructed is the envelope. But they also acknowledge that in some cases you can't do that test. And in some cases you may be asked to be doing an operational test for ASTM E3158. There's arguments about what's the value of that test, what can you conclude from that test? But what this says is, I'm going to test the building in its operational state. And so it at least gives people an option to say, what's the energy usage of this at a point in time when we tested? But it acknowledges that as an option and talks about, if you are going to do that, how do you do that successfully? And so these just show a lot of categories for how do you prepare the building for a proper air tightness test of the envelope. But if you're doing an operational test, the building's in use, you would set the building up differently. And in many cases, you're just leaving things as found. But there still are some things that you want to make sure that you set up properly. Jake, that's kind of as far as I got in terms of setting up the opportunity. I mean, there are people who are a lot more knowledgeable about all of these than us, including the Air Barrier Association of America, ABA, and many others. Most of the engineering firms that have been doing this for a long time are very well versed in these things. So I didn't want us to spend too much time on it.
Yeah.
Okay, so if you're okay, I think we're going to just keep moving, Jake, and we're going to move into some of our capabilities. And we're mostly going to talk about things we've been working on to try and make this testing easier with Minneapolis blower doors.
Okay, awesome, thanks. So this is just kind of level setting here. The main thing is, this concept of multifamily testing. I think of it in units. So you're using a single fan on a residential house in most cases. When you move up to the bigger buildings, I start thinking of it in doorways and in 3-fan setups. So when we set up our gauges and our fans, because of how our gauges work, we can use 2 gauges to operate 3 fans. So this is the gear that you need to do that. And on our first gauge, we'll set it up very similar to what you would on a single family test. Your channel A is typically getting an envelope pressure, B is going to get your fan pressure, which along with the ring, you convert to flow in the software. When you add that second and third fans, you don't need another envelope pressure. We've already got one from the first gauge. So because of how our fans are built and how they work with back pressure and being independent of it, we can then, on a second fan, just simply use that channel B. We've got an extra channel now on that second gauge. We can get the fan pressure from the third fan with that. So you'll set up 2 gauges, 3 fans, and then the next thing really is thinking about how you control all 3 of those fans. I again think of them as being in one unit and wanting to turn them all on at the same time, at the same speed. So in order to do that, we dedicate one of those 2 gauges in a setup to power all 3 fans. So in order to do that, there's a simple splitter cable that you see on the lower right there that will just split the signal to control the fans and run it from 1 gauge to all 3 fans, so that when the signal gets sent to run, all the fans get it at the same time. They all operate at the same time then. So
yeah, one of the things that I when I first started, it took me a while to understand. We talk about 3 fans and 2 gauges. And I think for a lot of people moving from 1 fan tests into small commercial buildings, this actually might be 3 fans might be the most they do. But this continues to go as you say, well, hold on, I might have 10 fans or 12 fans. Can you talk a little bit about that? Like you need to, depending on, you need 4 sides of the building for envelope, but then it's just 1 channel for each additional fan.
Yeah. I mean, the way I conceptually think about it is that instead of gauges and fans, I think about channels and fans. So I need a channel to measure a fan pressure to get a flow. I need a channel to get an envelope pressure. And typically on big buildings, you might need another channel to monitor an interior pressure to make sure that you're getting the full single zone condition so that your pressures are reaching all the exterior boundaries of the building. So it's more of a flexible setup where you kind of define what you need and then dedicate your channels from your gauges to accomplish that goal.
Yeah, that's great. So this says 2 gauges and 3 fans, but the right way to think about it is channels. I think that is the right way. How many channels do I need? If I decide I need 2 or 4, depending on the standard I'm trying to comply with for envelope, 2 or 1 or whatever for interior pressure uniformity, single zone, then I need 1 channel for every additional fan. And the benefit of that is it starts to get a lot less cables and a lot less gauges to set up. And it does, on a bigger test, minimize the amount of complexity from a gauge perspective.
Yeah. So if we were going to go from a 3 fan to a 6 fan, so I've got my 2 gauges right there, my 4 channels, they're all being occupied in this setup here. If I add 6 or 3 more fans to that, I'll have three more channels I need, which is a gauge and a half. Well, gauges come in units of two for blower door testing. So I need another 2 gauges for the next 3 fans as well, but I'd have an open channel there. So then when I get to, say, going up to 9 fans, I would just need an additional gauge. I'd have an extra channel from my second set of fans. I could add 1 more gauge. And so you'd end up having 5 gauges running 9 fans. And so as you keep scaling, the distance between the number of fans and number of gauges starts to keep creeping apart.
So I'll show that concept a little bit later when we start talking about tools to help the planning process. You know, when you're doing these multifan, that it calculates the number of fans you need based on the size of the building. But then as you figure out how many fans you need, will also help you figure out how many gauges.
So we've come up with a couple setup guides for, again, thinking of big building testing in units of 3 fans. So this is part of some new guidance that we have out that just steps through thinking of those single units and stepping through the entire process. So there's a lot going on with these documents. They're kind of meant to be a cheat sheet that you could, possibly print out and keep with equipment or just pull it up on your phone. But it goes through in point 1 there, installing the fans and whether they are set up to pressurize or depressurize, assuming you're inside the building. How would you set up the tubing? It's slightly different with how the fans are referenced if you're pressurizing or depressurizing the building. So that lays that out in the first step there. The second one goes through the power setup, which I described earlier, the concept that 1 gauge is going to send a signal to all 3 fans for them to operate. And then the next part of it really is once you're physically set up in the door and you've got power going to each fan, is networking your gauges so you can pull all that data off the gauges while A, to run the test, and then B, to pull the data back and compile your report. So step 3 goes through a networking guide. There are a lot of different ways that you can tackle networking your gauges. So step 3 kind of steps through some of that. And then 4 and the links on the right give you the back talks about how to set up a Teclog session and how to initiate a test and step through a test. So the idea is that from setup all the way through running a test, you'd have kind of in a 1-page document the major points that you'd need.
And this one is saying if you're inside the building, which is the way most people test, right?
Yeah.
But you also made one for what happens if you are outside the building.
Yeah, slightly different. I mean, very, very similar. The tubing's slightly different on the 2 setups, so this kind of keeps everything straight.
Yeah, and so again, you'll see this later, but all of these reference kind of guides for field use are up on our website, and I'll show you that as we get through the presentation and start talking about resources. Okay.
So another concept is your tubes versus cables. This is something we talk about whenever we are training somebody on how to use equipment. And the idea here is just that if you are taking data, you want to be sure that the pressure data you're getting when you do a big building test is coming from the fans, or if it's coming from something you can't control, like the wind, that you have a good idea that you're isolating just that thing. So in order to do that, you need to understand some of the errors that can occur when you're doing a test that could mess that measurement up. So I think most people that have done a test have seen, when somebody opens a door when the fans are on and they see a huge pressure drop because the envelope's been opened up. The opposite can happen when somebody steps on a tube. It'll compress that small tube and can cause a huge pressure spike. Typically, they're short-lived. They happen, they go away. But there's some other ones that are a little bit more insidious. They're kind of harder to see and understand, or harder to see, I should say. And when you start getting tubes that are over 100 feet, you can start to run into to the tube itself starting to change the pressure. So you're not measuring exactly the pressure that you would if you had a very short tube, but the inside of the tube is actually starting to change that pressure a little bit, which would mess up your readings. If you have tubes that have smaller diameters, that can increase that sort of error that can happen. Another very common one is temperature change around a tube. So if a tube is running a long distance, and the long distance just more opportunity for this to happen. But if you've got a longer tube and there's a portion of it that's got sun, coming through a window and it's low angle sun, it's very hot, you can start to have the air in the tube start to heat up, and we know heated air expands. It'll start to create a pressure inside the tube, and that's not a pressure that's caused by your fan or by the wind. It's an error that you don't want in your measurement. Holding tubes vertically, running them up and down a building, they can have little stack effects happening inside of them. I talked with a guy recently who had his Teclog session open. He had his tubes all run, and he was seeing this very odd kind of pressure that was, I think it was decreasing. And we went through, and he had a large length of tube that he had run through an area that had a cooler in it. So it had a section of it that was getting very cold. So no fans were on. This was an interior tube. It shouldn't have really been moving at all, but it was an example of this idea. So
multiple densities inside that tube based on the temperatures it was exposed to.
Yeah, so that's a long way around to just say as a mantra, man, if you can run short tubes, that helps to not necessarily eliminate all of those, but it greatly reduces the potential impact on your test. So if you run shorter tubes and you have a lot of fans and gauges that are spread out, the consequence of that is that you're going to need to run longer cables to connect those gauges. So short tubes, long cables is really a kind of a mantra that we hammer home, because we feel like that helps get better, cleaner results when you do a test.
Yeah, and all we're pulling a couple of the slides we use in our training that we give. At the end of this, we'll highlight that we do have a training coming up if you're interested in it. And so we'll keep moving now, but that is one of the themes of our training, and we show people these effects during that training. So, oops, I didn't know there was a build on that. Sorry about that, Jake, but you had talked about this. So you said, hey, if you run short tubes, you got to run longer cables. And that's kind of a lead into this discussion around the DG1000 gauge and sort of the options we have for communicating back. Cables, Ethernet cables are certainly one, but it's not the only way.
Yep. Yeah, so the DG1000's got 4 or 5 different ways that you can network it together, and understanding that and using that, the variety can help make, I think, for simpler setups in some cases and very robust setups when you have the need for it. So I'm going to step through just quickly through our guide and just talk about the different ways that you can connect to DG1000. So the first one on here is just using Wi-Fi. So we've had this gauge out for 10 years now. And we worked really hard on this Wi-Fi, and it works really well. So if you have line of sight, I used to kind of say about 100 feet, is good. Highly dependent though on the environment that you're in. Metal racking, rebar, concrete walls. There's a lot of things that can limit Wi-Fi signals, but in an open area, very reliable. So the DG1000 can generate a Wi-Fi signal similar to what a router can do. So you can just take a laptop out and have one of the gauges generate a Wi-Fi signal. All the other gauges you use that are within range can join. They'll see and join that network, and you can have the laptop join it, and you'll have a fully wireless setup. If you want to, you can grab a router and have it generate the Wi-Fi signal, and then have every every other device join that. So you kind of have flexibility in whether the gauge it takes the place of the router, so you can reduce having some extra hardware that is another potential breakpoint in a system. Or if you've got a great router or a router with different ranges on it, you can certainly use that and have the gauges join it. So I always start with Wi-Fi. And in my head, like I said, 100 feet and under is kind of my rule of thumb for when I'll start with that. Once I start spreading out where I have things further apart than that, then I'll go to some of these other options.
Yeah, I think this is also something that you show in the training of our, at our building, is some of the there's this trade-off of, is it easier and faster to use Wi-Fi, but in some situations it's just not reliable enough. But you kind of show the limits of that, like what is a good rule of thumb. But if you can get away with Wi-Fi and it's a 3-fan, 6-fan test where you have that, it's just plain faster and easier. So,
and I will say too that some folks will try to join on a bigger building. They'll join an existing Wi-Fi network.
Yeah.
I personally don't do that, and I haven't heard anybody jumping up and down saying it works great, because you give up a lot of control when you do that. You don't know what else is happening on that network, and having a dedicated network helps to have a bit more control of that.
Okay, well, let's keep going. The other end of the spectrum, I guess, right, Jake?
Yeah. So longer range, when you're getting outside of that 100-foot range, in my mind, I go to Ethernet. So the gauges also have Ethernet ports on them, and you can take those, run run Cat5 cable out from a router to the gauges, and then back to the laptop or the computer. So this image here shows a switch in the center there and a router. You would need a router that will assign the IP address to each one of the gauges. So you can use a router and a switch if you need more ports. Or if your router has enough ports in it for your gauges, you can get rid of the switch and just have a router there. Ethernet is great for long distances. It's very reliable. It's a physical thing. You have complete control of it. The main thing with Ethernet cable is just being, I think, fastidious with checking it before each test, because it can be damaged, and cabling and tubing can get holes in it, and cabling can have broken connections. So just making sure that as you have an arsenal of Ethernet wire that builds up when you start doing building tests, that you check that regularly, I think is important. But this is a very robust kind of tried and true method for doing very large buildings where you need to span long distances.
Okay, and now in between, right?
Yeah, and the in between is saying, hey, let's say we've got a few doors with 3 fans in them, and they're on opposite ends of a big building. Based on my previous picture there, you'd be running a lot of Ethernet cable back, or adding switches and a bunch of little strands out at each kind of end of these 2 separate satellite installations of fans. So another option is you can use a bridge mode, where you can have a gauge that is connected in the wired Ethernet way, and it can then also generate a Wi-Fi signal, and then the gauges around it. So again, say there's 6 fans far away from you, you could run one Ethernet cable out to one gauge, have it broadcast Wi-Fi, and then have the remaining gauges that are, again, line of sight of 100 feet now. So you have this huge bubble around that one gauge, where you could connect more gauges to it, and then they will send all of their information, dedicated information, down that one Ethernet cable back to the computer, so we can get access to it. So it's a handy way to kind of do a hub and spoke type of setup, where you can send long runs out and then use your Wi-Fi quickly to grab more gauges in the area. Yeah,
great. Okay, so that's why we have these options. And then Jake, I think you were talking a little bit about this.
This is a layout of our new building, and it's 156 feet long. And so on the red ones there, I've multiple times had gauges that were not line of sight, that were over 100 feet, and ran tests, and it didn't lose any signal at all. It was fantastic. And then going corner to corner, I've also tested the building in that direction as well. And that's much longer. And I think I actually haven't tried Wi-Fi. I think I need to do that actually.
Yeah. Well, maybe next time.
I'll run Ethernet down the middle of the building. And then at one of the corners where I'll have multiple fans, I'll use that method we just talked about. So I'll run one cable and then Wi-Fi and connect all the gauges out at that branch. So it's just an example. And our building's not super easy to test. I mean, it's not the biggest building in the world, but it definitely has a lot of, it's kind of a hostile Wi-Fi environment. There's a lot of metal racking. There's, it's not just an open warehouse.
Yeah. Jake, we talked about why you would want to use Wi-Fi, either if it is close enough or in this situation where you're doing a single Ethernet and then you're doing Wi-Fi. And to help that, this is one of the things that we've just come out with recently. This is free update to your DG1000s if you've got them. So you got to make sure you bring your DG1000 into a Wi-Fi network and connect it, and then it will have an update available. And in that free update, you get this capability, which is of interest if you're doing more of this multi-fan testing.
But yeah, so the idea is that when you start the network that is broadcast by a gauge, all the gauges that join it, it's just like any other Wi-Fi network. You'll have to identify the network and then enter the password to get onto it. We've now just changed that so that when a DG1000 sees a network coming from another gauge, another DG1000, it just skips that. And as soon as it sees it and you select it, it will join it without the password. So it's a little quality of life feature, but if you're trying to connect 16 gauges, you can spend a lot of time punching in passwords. Now they'll just automatically connect.
Yeah, DG1000 says, well, if I'm trying to connect to another DG1000 network, no password needed, let's move.
Yep.
Okay, and that was suggested by one of our users, and it is something that is implemented now. Yep. So similarly, Jake, I know we've made some updates to Teclog that are these similar sort of efficiency improvement type things. Can you just take us through Teclog? And let me introduce one thing though that we didn't get into the slides. So some of you may be watching this have only used single fan tests, and maybe you've heard of Teclog from us, but you're using either like an old software program like TechTite, or you're using our newer app Autotest to capture all your data and build reports. If you are making reports. Once you get past one fan, though, you have to move to Teclog. This is a Windows-based program that you have to have a PC for. And so that's the multi-fan software for big building testing for us. So Jake, take us through some of the updates that have been done. Oh, by the way, just like our apps, it's free of charge. You can download it directly from our website. I'll show you that at the end of this presentation.
Okay. So yeah, I'll step through this quickly. We're getting a bunch of questions too, so I want to save some time for that. So
I can't see those. So yeah, you'll have to.
I'll run through this. So when you launch Teclog, you come to this screen. There's a lot going on this screen.
Oh, yeah.
Oh, sorry. Yeah. You hit the configuration setting button, and then so it brings you to this configuration screen. Everything along the left vertical side of it is the graph and some kind of advanced features, but everything's kind of shown out there. If you need it, you want to change the graph, you can. The right side is really your device settings, is really the action area where you're setting up your network of gauges and then telling, like I said before, what is each channel doing? Because one gauge might have a building pressure on channel A, one of them might have another fan pressure on channel A. So that needs to be delineated up front so that Teclog interprets those pressures that are coming back to it correctly. So we come to this screen right away, and the first thing you do is you hit the scan for ports and devices, which is kind of right in the middle there. And when you scan for the ports and devices, it will then go and look for every DG1000 that it can see, it being the computer that's running Teclog. So you have a router connected to that laptop through Ethernet or Wi-Fi, and that router has cables going, to other end of a building, and there's many gauges out there, it will see those. If you also have a Wi-Fi network running and there's some gauges that are on Wi-Fi, whether they're bridged or not, or you have something plugged in with USB, which is another option, it will look and scan for all devices that it can see. So you'll get a screen like this which will show all the TEC gauges that it can see. And in the past, it would just grab them all, and there they were. We've now just done this kind of simple thing that when you make the scan, that all the serial numbers of the gauges are ordered, so you can kind of, if you've got a fleet of gauges that you're using over and over again, they'll scan and come up in a repeatable way, so that's a little bit easier for you to identify them and then set the specific channel settings for each of the gauges. So when you get done with that, then you go through this device settings section above that, where you'll go and you name each gauge. Some people still have DG 700s. You can have 700s and 1000s on the same network. So you go through and say, hey, what type of gauge is this? And then you identify where it is. Once you're done with that, now you open up each gauge itself and say specifically, channel A is doing X, channel B is doing Y, and you'll say exactly what each one's doing, and you'll give them specific names, which really helps later on when you're running a test with many fans, having good labeling on that so you know what each channel of each gauge is actually measuring, can really smooth your test out. So this is the next step then when you identify all that. There's some more stuff in here we don't really have time to go into, but that, there's a lot of action that happens on that screen.
So that's how we set it up. You're setting up all of your gauges and all of your channels, let's say, for the test. Then once you're done with that, let me take you back, and you hit OK, and then you finish up by hitting OK. Then you get to this screen. You go to recording, start recording. That means I'm going to start logging and keeping track of my tests. You name it, and then you get to this screen.
Yeah, so then this is your data acquisition screen. I mean, Teclog is a very powerful data logging software, so it will start a live recording. Anything that happens once you hit start record, you can have access to later. And kind of one of the great features about it is that if you need to retest or go back and look at a certain pressure, you've got this visual display of everything that happened during your test. So it brings you to this screen, you start the test, and just as another kind of quality of life feature, whether you're going to pressurize a building or depressurize a building, as I said earlier, there's one tubing change that is impacted by that. So now when you start a logging session and you're in, or whenever you toggle between pressurize and depressurize, you'll get this pop-up that'll say, hey, assuming you're inside the building, and here's how you set up your Model 3 fan. So just a little indicator of how to make sure that your tubing is set up so you get good answers. Okay,
very good. So, I'll show you another one of the resources that we have on our website is a couple of videos about how to set up Teclog. It is one of these originally developed for research of logging data and then quickly applied for big building testing. And so its user interface, it's not wizard oriented. You have to kind of go through the learning curve, and then it's very powerful. It gives you a lot of visual clues of what's going on, but there's a learning curve. And so we have 2 videos that take you through all of the tips and tricks of setting up Teclog and getting familiar with its shortcut keys and things like that. Okay, Jake, I think we're almost through this section, but there's one more thing we wanted to talk about.
Yeah, so one of the big things with doing a big building test is how many fans do I need, right? So the process of planning for that. So, a big part of it at the end of the day comes down to how big is this building? What is the standard we think they're or the target they're going to hit based on the standard as far as tightness? We don't know what the tightness is. That's what we're there for. But let's plan for the maximum amount of CFM that building will need to hit that failure mark, basically. So everything in past
spec.
Yeah, you don't really plan. You can bring extra fans, certainly, but on some of the big buildings, as long as you can cover enough flow so that building, so you're 1 CFM over what they need to pass, or a bit more than that, is kind of where a lot of people will land. So we use a calculator tool where you'll plug in those relevant inputs. Your test pressure is relevant. Fans at higher test pressures flow less than they do at lower pressures. So, you need to know the test pressure and the specification for the target
It's
and
usually CFM 75, right? In bigger buildings, that's usually what they're tested at. CFM 50 in residential, CFM 75 for bigger buildings. Yeah.
Yep. And so we use this calculator then to back out the amount of flow that we would need to pressurize that building at that certain leakage. So you use this calculator to do that.
Yep.
And we'll kick out an answer.
And one of the things that we've run into recently is, people are testing bigger and bigger buildings. And, in some cases, the answer doesn't come out as, oh, you need 6 or 8. It comes out, you need 27 or 40. And so we've been challenged, what do I do in those situations? What are my options? And so Jake, you want to take us through a little bit of that with what we've done in Teclog?
Yeah, so Teclog already right now supports 16 gauges with one iteration of it. So this is kind of part of the flexibility of it. You can run 2 versions of Teclog on the same computer and
at the same time.
At the same time, thank you, and basically double that. So you could run 32 gauges off 2 iterations of Teclog. So this is just a visual of, hey, I need 40 fans. Okay, that's a lot. That's a really big building or a very leaky building. So this is an example. So on the left there, Teclog iteration 1, I open it up like normal, and I've got 16 gauges, 32 channels. Let's say I want to get a building pressure on each side of this building, cardinal directions, and I need a minimum 1 interior pressure. That leaves me 27 fans. That's a lot. That's hopefully most jobs you'll ever do. But if you run into something really, really large, you can then launch another version of Teclog. The networking that you did to get all the gauges set up still applies. And you can then take, in this case, 4 more gauges for 14 channels and get your additional 13 fans with 1 to spare and run the test. So
I think, yeah, well, oh, sorry, Jake, yeah.
No, I was just going to step through how to do that.
Before you do, I think the one thing I want to highlight is, so what's the value of this running 2 versions, 2 concurrent Teclogs in this case? They're all on 1 computer with 1 timestamp. All your PORs are really one. They can be combined into 1 report that shows all of the flows and allows you to get to 1 report for testing that building, even if there's, in this case, 64 channels. So if you had 4 envelopes, that's another, 60 channels, which if you're checking interior, maybe up to 58 fans, so meaning a lot, and it can all be on 1 computer. Okay. Back to you, Jake.
Yeah. So just to step through it really quick, you would network your gauges as normal. So all of those gauges, regardless of which version of Teclog is recording their data, get networked the same. So everything we talked about before applies. Configuring the gauges, the first 16, that's just like what we've talked about as well. It's your standard setup. And then once you have your first 16 set up, so you've basically maxed out what Teclog can do, you launch that second version of it, and then you literally, side by side, or one of them in the background and 1 in front, you scan for ports and devices on your second iteration of Teclog. It will scan your whole network again. Anything that's already been identified and used and in your first version of Teclog is excluded. So it will just see set up gauges.
Dedicated. Yeah, the ones that are not already being in communication. Yeah.
Right. So you then just go through and take those remaining number of gauges and do the setup exactly as you would for that. So notes.
This is the kind of thing. Oh, sorry, Jake.
I was just saying two notes is just that I wouldn't. I'd make sure that there. I'd think in units of 3. I obviously want 2 fans in the same door. Going to different versions. But so that's my only point there.
Yeah. Okay. And and this is the kind of thing that we would go through. We've, done some specific, if you are in a situation where you need this, call us, we will take you through it. We're developing a guide for this. We do this in our training, and as we do our next round of training that I'm going to tell you about, this will become available. But if you're running into a situation where you're doing a really big building, please reach out to us and we'll help you plan that and make sure that you're ready for that kind of test. You know, the other thing that comes up on this, so, okay, Teclog now supports this. I've got all this. What happens is, in a lot of cases, you just don't have enough fans in your possession. And so another thing that we've added is a rental program that's more formal for commercial building testing. And so we get a lot of questions where people say, hey, I need another 3 fans for this test. I've got 6, you know, in my company, but we need 9 for this test. And we now have a program that is available. It's the details are out on our website now, and you can see how does that program work. I'm just going to take you through it really quick. You essentially can rent a fan for 15-day period. That's 15 business days, with the intent that it would be on site for you for 10 days, 2 weeks essentially. And then the other week is for logistics of shipping on both sides. And so it's 15 days from our dock back to our dock. All right. And, you know, you can order a kit 3, which has 3 fans and 3 gauges, a 2, which is 2 fans and 2 gauges and 1. And we do that just to keep the logistics simpler for us, so that we can stock these and have them available. Okay. Did I lose you guys?
Nope, we're in there.
Okay, I no longer have control. So something locked up. Okay, so the other part of this program is there's a process out on our website. I'm going to stop sharing for a second and see if I can. Can you still hear me, Jake?
Yep.
Okay, something just locked up. So let me come back.
I can see everything's moving now for me. I can see her.
Yep. So let's just jump to this slide. Okay. So this is on our website too. There's really, you know, sort of a 5-step process, or really 4-step. You fill out an application document. Why do we want you to do that? Tell us why you need the fans so that we can help you plan and get exactly what you need. We'll do a review after you fill out this form. Then we'll talk with you and make sure it's all planned out. And then you'll sign. It's a 2-page front back agreement for the 15-day rental. Then all the way up to 15 days before your reservation date. Okay, because reservations happen and other people need those fans. And so you have a reservation date, but if you need to move it 15 business days before, you can move it without any penalty. But if you start getting inside that schedule, and so that's really your drive to say, stay connected with us and make sure you communicate to us if that test is moving, which a lot of times on projects, obviously things continue to move out. And then if you move it more than 15 days prior for us, then we won't charge you anything for a change in reservation. You don't put any money down. You only pay for the rental when it is shipping. So in order for us to ship, you pay and then it goes out. So a lot more details on our website for that, but this is something that really is helpful as people are not ready to make a big investment in more fans yet, because they're still trying to figure out, do I want to do this commercial testing? But it helps them meet that peak capacity they need for a given test and grow into it. The last thing I want to talk about in terms of new stuff for commercial is we now have 10-foot commercial frames and panels available. And so this is, we've had several requests for this over the years. I've got 2 versions here that I'm showing in the case. This one is our standard 8-foot, and this one is the 10-foot. Why did I bother to show you? Because when they break down, this one's a foot taller still, right? And so you can only break it down so far. You don't want to buy this big one. Not only is it really expensive because we don't get much demand for them yet, and so this is really low volume production for us, but we want people to be aware of it. If you need it, you know, and people start to say, no, I'm seeing a lot of 10-foot doors where I need a bigger frame, then, you know, the price will probably come down as we move more volume to it, but it is available. We have a limited quantity in stock right now, and then the lead times will be a bit longer. But if you say, oh, I'm not really sure I need that, you probably don't want it. That's our message, because it doesn't store as well. It is kind of, our frame is already sort of long and clunky, and this makes it worse that way. And so this comparison just shows you like an 8-inch residential, which is 45 and 96. an 8-foot commercial one, which is a little wider, but also 8 feet tall. And then this new one is 48 by 120. Now you can use this on an 8-foot door. The 10-inch, the panel is obviously bigger, and we've added some Velcro so you can sort of roll it up at the top. So it does work that way. Anyway, this is available. It's not on our website store, but if you're interested in it, you can give us a call, and we can take you through it. Okay. Last 5 minutes here, I'm going to take you through, and then we'll open up for any questions that have come in and try and answer those. Upcoming events. So the big announcement that we're excited about is, Airbury Association of America, their national conference, coincidentally, is in Minneapolis this year in May 5th and 6th. Right after that, we're holding a whole building air tightness testing, just TEC, at our new training center. And then the Monday, so the conference is a Tuesday, Wednesday. The Monday before, we're having a pre-conference party. So if you come in for that conference and you come in a little early, we'll have buses taking you from the hotel, the conference hotel in Minneapolis, over to our facility. We'll be having food and beverages, both alcoholic and non, flowing freely, and it should be a really fun time. And you can come see our new space. This is our new building. It's on the east side of the Twin Cities, and we really encourage you to stay connected with us on our newsletter. That will help you stay connected with what we're doing. This has been a big investment for us. We're trying to make this a place where we advance building diagnostics. That's our role in the world, and so this is intended that we can help advance that. But we're not trying to become a training organization alone. We have a lot of great customers and partners who do training. We're trying to make this more of a community where we train trainers and talk about the biggest challenges that you're seeing and how we can make it easier to do good work. So this is a view of what we have right now. This is the training center. We've got a BPI test house inside our building. We have an HVAC lab that we've started. There's stuff on carts, but there's also an HVAC lab planned. And then there's an addition that we're working on that will be for multifamily specific. So another lab, but dedicated to multifamily testing, because that is one of the biggest challenges for people, is to figure out how they're going to do that. There's also other the trainers coming up starting this fall. So encourage you to sign up for our newsletter and stay connected so that you can be aware of those announcements. These are just some of the trainers. Obviously, it's the TEC staff, including Gary and Steve and Colin and me, Chris Hughes, Jake, and Tessa Murray. So people with a lot of background and a lot of experience out in the field, especially Chris, Jake, and Tessa, with their years of experience doing these tests, in addition to Gary and Colin and Steve with their background technically. And this is just an example of a party we held last year at our grand opening. Just, you can see some of the people coming through. We have a history museum here about blower doors. So if you're coming in for this ABBA event, we really would love to see you come in early and come on over, or stay late for the training. One of the benefits we get is ABBA member Nate Gusakov, who is on some of the standards committees for ASTM. He's actually going to be in town for the conference, and he's going to join us for the training on May 7th and 8th at our building. So the training is really going through all the detail of what you just saw Jake and I do at a high level. How do I do these tests with multiple fans? Okay. And Nate has a bunch of field experience and, has a lot of really great knowledge to share in terms of, issues he's seen in the field, in addition to just being taught how all of our products work. So we're super honored that Nate, and super thankful that Nate's making time to help us train. It's a day and a half. So it's Thursday, full day, done by Friday at 1 p.m. so people can fly home and be home by the evening. And this is the agenda. So it's just, how do you perform the test and how do you plan and that sort of thing. These are just some shots from some previous ones we've done. We do go up on our roof. We own the building. We're the only occupant, so we can run the test in our building. We do training in the training center on tents and in the house. We take you through all the Teclog stuff, and we show how to test all the equipment. We'll go up on our roof and look at the mechanicals and how we're going to seal that and talk through some of those considerations. And then on the last day, on Friday morning, you test the building. And so you're getting the experience of actually testing our building after you spend a day going through how do we do this? Okay. So that's the goal. The other thing we have there is Nate, believe it or not, Nate takes a whole bunch of photos of all the blower door tests he runs. And we have a nice hall, the blower door hall down in our building where we displayed those. And, we run a contest to say, hey, if you've got blower doors and you take photos of them, we run a contest to every year these will rotate. And there's also a calendar that comes out that shows the 12 photos that are hung in our hall. Okay, so that's all going on. This is this is our suggestion. Come on to the ABA conference in Minneapolis the first week of May. Come in early and join the party. I hope this works. I'm not sure. Actually, I'm not going to do it. But it should be a fun time. And you will have a food truck or maybe a couple food trucks. And we hope you can join us. This is last fall's event where we had a band. And, we have a bar, we have a patio. And it's just a ton of fun. So we'd love to see you. The last thing I want to say is people have gotten confused from, hey, are you guys like now trying to become a training organization? And the answer is no. We want to train BPI, ResNet trainers. We want to focus on the trainers. We don't want to replace them. We want to help make their job easier and better. And if you're looking for building science training or HVAC training, there are a whole bunch of alliance training organizations that are out there that do great work. Partners like NCI, Brian Orr in the HVAC school, Jim Bergman and the Measure Quick team, Joe Stiebrick at buildingscience.com, that everybody knows, and Coda at BSC, ACA, Craig Migliaccio, Alex Meany, Tim DeStasio, all the guys at Construction Instruction, obviously Air Barrier Association of America, which we've been talking about here. Randy Williams and the Green Building Advisor, BS and Beer, Build Network. I mean, there's just so many great training organizations depending on what you're looking for. Our job is to work with them, be challenged by them, and try and help from a diagnostics perspective. How can we help them do better training and better work? Okay, we're only 20 minutes from the Minneapolis-St. Paul Airport. Man, this is like I'm like a schlocky salesman here at the end here. But that's my last sales pitch. Please stay connected with us. We're super excited. We made a big investment, and we hope you'll come and join the community. That's really what it's all about. Okay, Jake, I think I'm going to stop that. Let me stop sharing. And what questions do we have that you can help us sort of answer?
I think most of them answered.
Okay.
Kyle Anders asked about just speak to the high-rise respect with long tube strategy. So yeah, that's exactly kind of that's the tough one right there is high-rise. So I mean, main one, don't run vertical tubing outside the building. That's like where it can have a stack effect and have weather conditions and wind moving it. So that's like the big no-no. If you have to have fans up high and down low, that's where long Ethernet to a bank of fans that have short tubes is precisely what we're talking about. There are some scenarios where you're going to do an interior pressure uniformity where you'll probably still need long tubing. So in those cases, just not having it run. Well, first of all, try to keep it in the same temperature area. Sometimes with fans, pressurizing a building, especially in Minneapolis this time of year, I mean, you're going to be blowing a lot of cold air in. So don't run those tubes, any tubes, right next to the fan. Try to keep them out of that channel of air that would cool it down. So yeah, those are some aspects of that.
Yeah. And we're not going to do justice to it on this, but the one thing I did want to say is if you come out to our website and you go on events and webinars, and so you click out and you come to event. If you scroll down, this is where you sign up. So this class we're talking about that Nate Gusakov is joining us for, it's May 7th and 8th, done by May 8th by 2 p.m. It will actually probably be at 1 p.m. You can sign up, just come on in, click the whole building air tightness testing training, and you can look at the tickets. It will give you all the details of what's available. We do limit this. We just opened this up. Actually, looks like one person's already signed up. We just opened this up, and so it's limited to 12. But if you are coming in for the Air Barrier Association conference, I think this would be a really great opportunity to spend a day and a half with us and get some more value from your trip. All right, and then we'll talk through these exact kinds of topics and questions that Jake was just trying to answer. All right. I think we're out of time. I don't know if there was anything else, but if you have other questions, you know how to reach us. Go out to our website and you can say, hey, support, and send us an email. Thanks so much for joining, and hope to see you in Minneapolis this spring.
Yep. See ya.
Thanks a lot, guys.